My name is Asia Farrar, and this is podcast number 3, Types of Discontinuity, for Professor Lewis's Calculus 1 class. For number 1, we are asked to use the continuity checklist in order to determine if function is continuous at x equals 2. So the first thing we have to do is look at f of x. In this case, this is f of 2. So f of 2 is 5 on this chart. Next, we have to find the limit of x approaches 2 of f of x, which does not exist, because when you're coming from the right of the graph, it is at 5, and when you're coming from the left to approach 2, it is at 1. So the function is not continuous. To write this out a little bit more, f of 2 is 5, and the limit as x approaches 2 of f of x does not exist, meaning that f of 2 is not equal to the limit of x approaches 2 of f of x, meaning that the function is not continuous. So for number 2, we are asked to use the continuity checklist in order to determine if the function is continuous at x equals -4. So we look at the graph at -4, we see that f of -4 is undefined because there's an open circle there. When we look at the limit of x approaches -4 of f of x, we see that it's 2, because the limit of -4 coming from the right is 2, and the limit of x approaches -4 from the left is also 2. To write this out, we have f of -4 equals undefined, and the limit of x approaches -4 of f of x equals 2. So f of -4 is not equal to the limit of x approaches -4 of f of x. For number 3, we are asked to see, does f of -1 exist? When we look at the graph, we see that f of -1, it does exist, and it exists at 3. f of -1 exists at 3 is right here. For number 4, we are asked, is the function defined at -2? So at -2, x equals -2, we see that there's an open circle, but we also see that there's a closed circle. So therefore, f of 2 equals 4. So yes, the function is defined. f of 2, 4. So for number 5, we are asked to state how continuity and domain are related. Continuity and domain are related because the domain is where f is continuous. If a problem says to find all numbers at f is continuous, they are asking you to find the domain, basically. For number 6, we have a problem given that is it says f of x equals 5x over square root of 8x minus 2. So we already know that since we have a radical, the denominator cannot be negative. well, anything inside of the radical cannot be negative. And we also know that since it's a fraction, the denominator cannot be 0. So in order to determine if the function is continuous, we have to set the denominator equals to 0. So we have to square both sides. We have to get rid of that radical. Then we have ax minus 2. We add 2 to both sides. Get 8x equals 2. Divide 8 by both sides. Now you have x is equal to 1/4. But we will not have equal signs because we have a radical. When we have a radical, we will either be using greater than or less than. So the function is continuous on all real numbers except for when x is less than or equal to 1/4. When we plug in 1/4 into this equation, we can see that 8 1/4 minus 2. When we solve for that, we get a 0. So it cannot be 1/4. X can only be less than or equal to 1/4. Meaning, the function is continuous on all real numbers except for when x is less than or equal to 1/4. So, for number 7, we are asked to also find out if the function, where the function is continuous. So here we go. We have g of x equals x minus 10 over x squared plus x minus 42. This is also a fraction, so we know that the denominator cannot be 0. So first we have to set the denominator equal to 0 in order to find out what numbers x cannot be. So we know that we can factor this. When we factor, we get x plus 7 times x minus 6 equals 0. Therefore, we have x is equal to negative 7 and 6. The function is continuous at all real numbers except for when x is negative 7 and when x is equal to 6. Okay, thank you very much for your time. And that is my podcast 3, Types of Discontinuity, for Professor Lucas, Calculus 1 class.